Hello and good morning or afternoon if you're watching this in the afternoon. So previously we discussed dilations, and dilations are going to be enlargements or shrinking of a figure, and specifically we're talking about triangles. To determine if they're similar, so they're not congruent because they're not exactly the same size, but they can be similar if they're the same shape and they've been reduced in size or they've enlarged in size by the same number, and we called that number the scale factor. So in doing so, to determine if two triangles are going to be similar or not, we're going to have to use proportional relationships. So I'm sure in the past you've talked about proportions being, a third of a cup, to a third is equivalent to 2/6, right? So these are proportions. So indirect measurement can be used to find unknown heights and distances using similar triangles. And proportional side lengths. Okay, so for instance, in this case, 1/3 equals 2/6. One might be the length of one side, and then 2 might be the length of the corresponding side. Okay, so either way, they are proportional. So let's look at a little bit of context here. So in this figure, we see that the observer is looking up at a building, and both the observer and the building are casting shadows. So the observer here and the building, those are corresponding sides to these triangles, okay? Those are what are proportional to one another, okay? And the building are casting shadows that can be measured. The observer's height can also be measured. So we can measure the height, we can measure the height of the building, we can measure the observer's height, and we can measure the shadows that are cast out from both of them, okay? So let's identify this as being two triangles, two similar triangles, and we're going to label them with heights and lengths so that we can see if we can find the similar triangles that are formed. Okay, so here we labeled them with some points so that we can identify those triangles a little easier. So let's look here. We have a 6 foot tall man. Okay, so this man here is 6 feet tall, casting a 2 foot long shadow. So his shadow is 2 feet. And he's looking up at a building that casts a 22 foot long shadow. So his shadow is 22 feet long. Use the figure below to help calculate the height of the building. Okay, so the first question is going to ask us which segment represents the height of the building. Okay, so the height of the building is here. So which segment on this triangle is going to represent the height of the building? And you might have said PT. So PT is going to be the height of the building. On the figure, let's label the segments that represent the height of the man. So we already figured out that this was the height of the man was 6 feet. So SQ represents the height of the man. So we're going to label that as being 6. And the shadows with their lengths. So we have the shadow of the man, which is QR. So we said that was 2. And then the shadow of the building, which is PQ, and we said that was 22. Okay? So in this case, which triangles are going to be similar in this figure? So you may have said that the triangles that are similar are going to be PRT, and that's triangle PRT. And the way that we show that they are similar is either by one squiggly line, or you can show it using this, a colon. Okay? So triangle PRT is similar to triangle QRS. Okay, so these two triangles are similar, so we're going to try and figure out proportions to be able to determine different missing features if we need them. So the next says, what triangles are, so we already answered that question. Write a proportion that shows the relationship between the corresponding segments in the triangles. Well, going back, we know that PT, let's just look at PT first. So that's the height of the building. So PT is going to be proportional to, what side is corresponding? Well, QS. So those are going to be proportional to one another. Okay? So these are always going to be your corresponding sides. And we will need to keep them consistent throughout the proportions. So if my larger triangle is the one that is on top, then it will need to stay as the one on top. Okay, so let's look at a different corresponding side. So let's look at the shadows. So we know that PR is corresponding to QR. Okay, so these proportions are set up in this way. Well, do we know what, now we'll just kind of fill in the blank. Do we know what PT is? PT, we do not know the height of the building yet. Okay, so we're going to leave that as this. It's like our missing element. QS. QS we know is the height of the man, which is 6 feet. And then PR. PR is going to be the shadow of the building plus the shadow of the man. So we know that that is 22 plus 2, which is 24. And then QR is 2. Okay, so when this is complete, you can do it a couple of ways. You can say, well, 24 divided by 2, I know that that is 12. So something over here divided by 6 has to also equal 12. Okay? Or you can do this in a way of cross multiplication, which you may have learned in previous years. So we can say 6 times 24 equals 2 times PT. PT being our unknown length. Okay? 6 times 24, let me pull out a calculator, is 144 equals 2 PT, which means we will need to divide both sides by 2. So then PT is going to equal 144 divided by 2. Which is 72. So 72 feet is the height of the building. It is PT, which we know is the height of the building. So PT equals 72. Okay. So that is all for using proportional relationships. I think that this will help you to identify like missing sides of triangles and putting it into real world context if you're looking at these shadows. So tune in to the next video.